Okay, class, we are going to continue. Let's see here. What we want to do now is let's take a look at the XY plane. So there is our coordinate system. Now, what we can do for any ordered pair that happens to lie in this plane, and don't forget, these are quadrants, right? We label these quadrants 1, 2, 3, and 4, right? And that's because our rotation goes this way. So our rotation goes from quadrant 1 to 2 to 3 to 4. So that's those are the labels that we use there. Now if I pick any point, any ordered pair that is out here, and I'm going to pick the obvious one that is going to be the easiest for us. I'm going to pick the ordered pair. Let's go down here. I'm going to pick the ordered pair 4, 3. That would be this one right here. So that is the 4, comma 3. And what I can do is I'm going to go ahead and draw my radius out to it. So basically what we're going to picture here is that this arrow was laying on the x-axis and I rotated it counterclockwise and it stopped at the ordered pair 4, 3. From there, what I'm going to do is I'm going to go ahead and drop a vertical line down to the x-axis. And basically what I've done is I have just created I've created my right triangle. And this is angle theta. Because I know the coordinates of this point, I know that this length here is 3 and this length over here is 4. That means I could find this distance, which we will call r, by using the Pythagorean theorem. So r squared is going to be this x value. That's my x value of the ordered pair. This is the y value of the ordered pair. So basically r squared is x squared plus y squared. That's by the Pythagorean theorem. That means that in this case r squared is 4 squared plus 3 squared. You see where this is going. R squared therefore is 25. Square root both sides, we get r equals 5. There we go. That means then, now that we know all 3 sides of this right triangle, we could come up with all of the 6 trig functions. Because we know that sine is opposite over hypotenuse, so that's going to be 3/5. Sine is adjacent over hypotenuse, and the tangent is opposite over adjacent. If we invert each of those, then we can get their inverse functions. So cosecant and secant, flip the 4/5, and then the cotangent, we flip that, we get 4/3. Okay, nothing too earth-shattering about that, except that I want you to see the main learning point here is that if I am working in the XY plane, don't forget this is XY here, and I happen to rotate my arrow or my ray to any point that's in the XY plane, then I can figure out the length of the hypotenuse using Pythagorean's theorem, and then I could find these trig functions based on the lengths of the sides. Okay, so let's try this on something else, on a different point. There's my, see if I can grab this. There we go. Drag it down. Okay, so we'll stop it right there. What I'm going to go over now really is going to help us understand how to use the unit circle without really assuming that we understand what the unit circle is. All right, so let's see if that makes any sense here. Let's suppose I rotate my ray to some arbitrary angle. So we just know that there's going to be some rotation. and then it stops on a point out here. Okay, and we're not going to know what the angle is. We're just assuming that it's some arbitrary angle, but it is an angle that we will call theta. And the point that it stops over here is just going to be generically x comma y. Okay, and so basically when we look at these values, I have you can see here that this is a positive y value, and this happens to be a negative x value as determined on the xy plane, because that's where we're at, xy plane. All right, now if I ask you to find the sine and cosine of theta, well, what we're going to do is we are going to, and this is length r, by the way, we're calling that length r. Well, the sine theta is going to be the opposite over the hypotenuse. So I know it's going to be over r. And r is always going to be positive because r is something that would have been determined by the Pythagorean theorem. And so even if x and y happen to be negative values, they turn positive when we use them in Pythagorean's theorem. So r is always going to be positive. But in this case, now the side opposite of this angle is going to be always along the y-axis. Right, so basically, if we're talking about this triangle, the opposite side is going to be this length right here. And so that's measured with a positive y value. So that's going to be y over r. And that's going to be positive because it's going to be a positive divided by a positive. But let's consider the cosine of theta. That's the adjacent side, also divided by the hypotenuse, which is r. But in this case, the adjacent side happens to be the x-axis. And so that's going to be x over r. And when I say x and y here, I'm actually talking about the actual values here of the ordered pair where the rotation stopped, because that defines the length of these two sides. But in this case, though, this is going to be a negative value because my x is going to be a negative and the r value is a positive. So in this case, for this angle, which whatever the angle is, I know it is somewhere, this angle theta is going to be greater than 90, and it's going to be less than 180 because it's in the second quadrant. So therefore I know that this angle, whatever it is, it's going to have a positive sine value and it's going to have a negative cosine value. If we change things around, you can probably see where this is going. If I come down here to this ordered pair, again generically xy, and this happens to be the theta rotation, for that angle, which terminates in quadrant 4, I'm looking at my sine value, right? So if I look here, I have now a positive x and I have a negative y. So this happens to be a positive value, the y happens to be a negative for everything down here in the fourth quadrant. So what does that mean about my sine and cosine? Well, my sine is going to be the sine is going to be a positive over a positive because the opposite side, the opposite side here of the theta. So check that, that's going to be a negative when we're talking sine, because the sine of a function is the opposite over adjacent. So the opposite side here from theta is this one, which is the y value, and it happens to be negative. And so therefore the sine ratio is going to be negative. It's a negative divided by a positive. But when we look at the cosine of the angle, cosine is, as you remember, adjacent over hypotenuse. My hypotenuse is r, which is always positive. And the adjacent side, which is this side, is a positive x value. And so it's positive, positive over positive. So that would be a positive value. So I'm going to flip us over to the textbook. And you can see in the textbook, this is really the summary of what we've just been looking at. So here is my arbitrary point where my rotation has stopped. That's x, y. We could define all 6 of the trig functions in terms of the coordinates where the rotation stopped and the length of the hypotenuse, or the r value that extends from the origin out to that point, which we can always find r by Pythagorean's theorem. R squared is x squared plus y squared, as it shows right here. And so therefore sine is always going to be whatever that y coordinate is excuse me, over the r value. The inverse, which is the cosecant, would be the flip of that, which is r divided by y, assuming then that we're not along the x-axis where y would be 0. And then cosine is going to be the x value, the x coordinate divided by r. And tangent then would always be the y value divided by the x value. So we could extend this, if we go back to our notes here, we could extend this to any point that happens to be in the xy plane. I'm going to grab another coordinate system here. And what we'll do is we're going to find the 6 trig functions for some arbitrary angle where we are stopping here. So let's pick the point 2, 5. Okay, so I am at 2, 5. And that would mean then that this is my hypotenuse, r. Okay, and there is my y value. And then this along here is the x value. And so basically I've got a positive 2 and a positive 5. I can find the r value by taking the square root of x squared plus y squared, again Pythagorean's theorem. So the hypotenuse is going to be the square root of 4 plus 25, or root 29. And now I can say that sine theta is going to be the y value divided by r, which is the y value, which was 5. So 5 goes up in the numerator. That's the y value divided by root 29. If we rationalize root 29 over root 29, we get 5 root 29 over 29. I could also go to the tangent. Tangent is going to be y over x. Right? If we flip back to the textbook, tangent is y over x, provided that x is not 0, because if it was, then the tangent function is not defined. But in this case, the y value is 5. The x value is 2. So the tangent of whatever this angle is right here, again I didn't mark this, but that's the angle theta. So whatever that angle happens to be, which we haven't really looked to see how we would determine what the angle is, we'll look at that later, but whatever that angle happens to be, its tangent is going to be 2.5 or 5 halves. And if we understand this concept, these formulas, that r is the square root of x squared plus y squared, and we understand that sine of an angle theta is the y over the r, and the cosine is the x over the r, and that the tangent of that angle is going to be y over x. We can use this to understand a little bit more about the unit circle and why it is so valuable to us. At the end of this video, we'll do one more. Sorry folks, one more video.